Hi girls, and welcome back to Integrated Science. Last class we began looking at energy. So we looked at the concept of energy and we looked at the definition of energy. So energy is the ability to do work. And the formula for calculating energy or work done is energy is equal to force by distance. The SI unit of work and energy is the joule. 1 joule is equivalent to 1 Newton meter. When working questions and calculations involving work and energy, it must be ensured that our force is in newtons and that our distance is in meters. If they are in any other unit, they must be converted into that form before we can represent our answer as a joule. We look through the example on page 118. And now what I would like you all to do is read through table 10.1 and refamiliarize yourself with the different types of energy. You were already introduced to different types of energy way back at the end of Form 1. So this is just a small refresher of the different types of energy. Now we will be looking at the principle of conservation of energy. Last class I used an example with a tennis ball. So we had a tennis ball at some height h above ground. Now this ball, because it is at a fixed height, it's stationary. I'm holding the ball with my hand at that height. That ball would possess potential energy or stored energy. If I release the ball is going to start to drop towards the ground. As the ball comes closer and closer to the ground, the height is going to be decreased and the speed of the ball is going to go from 0, which is stationary, and be increasing as it comes along. Because the speed is increasing, the ball has motion. Because the ball is moving, it now possesses kinetic energy. And what we would notice if we have to calculate it is that potential energy will be decreasing. However, kinetic energy will be increasing. Eventually, just before that instant before the ball hits the ground, height is going to be 0. So kinetic energy will be maximum and potential energy will be minimum. So the potential energy is not lost, but it is rather converted into kinetic energy. So this can be explained by the principle of conservation of energy, that energy is neither created nor destroyed, but it can rather be converted or transformed into one type or one form to another. So this principle is extremely important when we are talking about energy. So you must learn this principle. So the principle of energy states that the energy cannot be created nor destroyed, but it can be transformed from one type to another. Right, so there are some examples here that you can read through, and I would like you all to go through these. The coconut falling on the ground is the same concept as the tennis ball that I was talking about. It's going to start off having gravitational potential energy due to the height. And then as it starts moving towards the ground, it's going to be gaining kinetic energy. It will also have heat and sound energy because of friction, right? So anytime work is being done, heat and sound energy tend to be a byproduct at some point in time. So some of the energy, will be converted from gravitational potential to kinetic, and then some of that will also be converted into heat and sound. So you all can go through the other examples here, which is vehicles driving over a pump, gasoline-fueled car accelerating on a level road, an aircraft taking off, charging a battery, electrical motor lifting a load, filament lamp. All of these are different examples that you can go through. If we look at a pendulum, I'm going to explain the transformation of energy that happens at a pendulum. In order for a pendulum to swing, B is going to be the stationary position it is hanging on. If I displace it to the left to position A, I am going to be giving that pendulum energy. So it will now possess potential energy. So potential energy is going to be maximum at this point because that's the maximum height the pendulum will be reached. Now when I let it go, at point B, it is at its lowest height. So what will happen? Pure potential energy is now going to be 0, but my kinetic energy will be maximum because at that position, it is going to be moving the fastest. Then the pendulum is going to start swinging upwards. As it starts swinging upwards, speed is going to be decreasing. As the speed decreases, it means kinetic energy is decreasing and height is going to be increasing. So then at point C, again, we will have maximum potential energy. And the energy changes in the pendulum will keep going back and forth, back and forth. And if we consider frictional forces to be negligible, then the pendulum will keep swinging forever. So next class, we will be looking at the internal combustion engine. So you all can start a read up on that. But for today, your main focus is to go through these different energy changes from page 119 and page 120. Please take note of any questions that you may have and we will clear it up in our next session.